All right, so let's go ahead and take the RMS value of a sine wave. So let me write my sine wave as some function of t, some peak value, the sine of omega t. Okay, volts, I guess. The units don't really matter here. What does matter is that in order to take this integral or to do this RMS, I would set up the problem like so, square root 1 over t, integral from 0 to t of my Vp, basically this whole signal that I have here, Vs of t squared. Let me just write that first, just like that. That's my formula. So if I wanted to go ahead and carry this out, I would say 1 over t, integral from 0 to t of Vp squared sine squared of t dt. And I could pull this Vp squared out, integral from 0 to t of sine squared of t dt. Okay, and then from here, sine squared, sorry, this whole time I've been writing t, it's supposed to be omega t. Whoops. Okay. Sine squared of omega t. There's a trig identity here. Maybe I should use a different color. Let's go with orange. Sine squared of omega t is equal to 1/2 times 1 minus cosine of 2 omega t. Okay? If that's the case, we can rewrite this. Actually, let me give myself some more room. I can rewrite this as Vp squared over t, integral from 0 to t of 1/2. Actually, I'll just pull the half out now just to make my life easier. 1 minus the cosine of 2 omega t dt. Okay. And now I can integrate pretty easily. I can say that this is the square root of Vp squared over 2t times t minus 1 over 2 omega sine of 2 omega t, and then that's going to be going from 0 to t here. And if I go ahead and multiply this out, I'm going to get Vp squared over 2t multiplied by t minus 1 over 2 omega sine of 2 omega t. And then that's going to be minus 0 minus 1 over 2 omega sine of 0. Just draw this out. Okay, so hopefully it's obvious that these two terms are 0, so that whole term goes to 0. It might not be as obvious that this term goes to 0, but if we look at the argument of the sine function, it's 2 omega t, which can be written as 2 times 2 pi times f times t, and t is 1 over f. So I can just say that these two cancel. And you should know that the sine of anything, n times 2 pi, is equal to 0, right? So sine of 2 times 2 pi would definitely be 0, so this whole term also goes to 0. All I'm left with here then is t. This t and this t cancel. And so what I'm left with is that Vs RMS is equal to the square root of Vp squared over 2, which is equal to Vp over root 2. Okay, and so that is the RMS value of my sine wave. So if I have my sine wave here, basically saying, of course we know our average value would be 0, but the RMS value VP is basically that's my peak value. This is my negative peak value. My RMS value, which I will put a little red star next to it, in red would be somewhere up here. Basically VP divided by root 2, or actually just get rid of this. Basically VP times 0.707, if I remember correctly. Let me throw 1 over root 2 in my calculator real quick, but I think that should be the value. Let's see, the square root of 2, 1 over that, 0.707, that's correct. Okay, so the RMS value would be right here at 0.707 times the VP. Okay, so that's the RMS value of a sine wave. So I derived it for you. If you want to memorize the fact that the RMS value of a sine wave is just the peak value divided by the square root of 2, that would be a good thing to memorize, because then you won't have to go through this derivation every time. However, it is important to know how to derive RMS values using this formula, because you won't always be working with sine waves. Sometimes you'll be working with square waves. Sometimes you'll be working with trapezoidal waves or triangle waves. You might be working with triangle waves, and you need to be able to calculate the RMS value using this formula for any given arbitrary wave, okay? So I'm going to end this video here. In the next couple of videos, we're going to do the RMS value of a couple of different square waves, just to show you this process again. I'm also going to show you a way to use this formula that's a little bit more intuitive than 0 to t and 1 over t. There's a different way that we can use this formula, basically write it in a different form using a change of variables. And that'll be nice and easy. It'll actually make this math a lot easier. I think that you'll probably appreciate it. So I'm going to go ahead and end this video, and in the next video, we'll do the RMS value of a square wave.